Right, here we go. Start of the live stream. We've got this little recording here we're going to be doing on fractions of powers and roots. It's going to be boosting from levels 6 to 7. So in the next half an hour, we're going to be looking at fractional powers and indices. So let's start off with our first one, which is going to be work out 9 to the minus 2. Now you should be able to do this without a calculator. I'll give you a few seconds to have a go at this, and then I'll go through it and discuss how you work this out. Okay, so we're going to look at 27 to the minus 2/3. I'll just scroll down a bit further to give myself some more space. The 27 to the minus 2/3. Well, let's do the minus first. So effectively what we've got is 1 over 27 to the 2/3. And the best way to look at this is to realise that this is equal to, we've got either going to do the square first or the third first. Now generally I reckon it's easier to do the third first, which is the same as the cube root. You have the nth root of the denominator here. Now we can just do this to the bottom because to the power of anything is just 1. So let's just put the 1 there. So we're going to do 27 cube root first. So I just wrote that in the wrong order. So that's just so we get 27 cube rooted, and we're then going to square it. It doesn't matter which order you do these. You could square first and then cube root, but squaring 27 is pretty tricky. So cube root the 27, we get 3. So we get 1 over 3 squared, which is just going to be 1/9. Right, have a go at the next one. Here it is on screen. Here you go. Okay, so let's do this one. So 4/5 to the minus 3. So the minus, now when you've got a fraction, if you have a over b to the minus any number, let's just say to the minus 1. Let's just say minus 2. Let's do minus 2, make it more relevant to this. The minus means we flip the fraction upside down. So we get b over a squared and then carry on. So bearing that in mind, we're going to flip this. So we're going to get 5 over 3 to the 3. So we're going to cube both the top and bottom. So 5 cubed is 5 times 5 times 5 is 125. 3 cubed is 27. And those don't really cancel down. So we get 125 over 27. Okay, try this one, guys. Right, so let's have a look at this one. It's getting a little bit trickier. So we've got 8 over 343 to the minus 1/3. So we're going to do the minus bit first. So that's going to flip that. So it's 343 over 8 to the 1/3. So you're going to cube root both the top and both the bottom. So we can see hopefully you can see the bottom one quite easily. Okay, we should see that's just 2. Now the top one's a bit of a bigger number. So what we can do is we can just think about numbers that this might be. If we did 5 cubed, that gets us to 125. If you do 6 cubed, you get to 6 times 64. You know, you might not remember what this is. So you do 6 times 4. You can see it's going to end in 4, so it's not going to work. Now 7 times 49. 9 times 7 gives you 3. 2 over. We get 7 times 4 gives us 28. Another 2. Wait, I made a mistake there. 9 times 7, sorry, is 63. I don't know what I was writing there. 9 times 7 is 63. 4 times 7 gives us 28. Plus the 6 gives us 343. So we can see 7 cubed gives us 343. So therefore, 343 cube rooted will be 7. So you get 7 over 2, your answer. Right, one last one, and then we'll move on. And 30 seconds to have a go at this. Okay, so let's do this one. 49 over 64 to the minus 3 over 2. So remember the minus flips it. So 64 over 49, we can get rid of that. And we got that to the 3 over 2. So let's square root this first. The 2 means square root, the 3 means cubed. Okay, so we square root the 64, we get 8. And we square root the 49, we get 7. And then we're going to cube both of those. So we get 7 cubed is 343. We've worked that one out already. And we want to do 8 times 64. So let's just do that. 8 times 4 is 32. So 2 down, 3 over. 8 times 6, 48. That's 512. So we get 512 over 3, 4, 3 for our answer. Let's move on to some square roots now. Have a go at both of these and see if you can do these in 30 seconds because these are a little bit easier. Okay, so we want to find the square root of 99. And the way to do this, there's several ways to do this. The first thing we want to do is try and find square numbers that go into 99, or you could do prime factorization. If you're not very good at finding square numbers, let's do prime factorization. So we know that's 9 times 11. Okay, and we can see that's 3 times 3. And what I say is everywhere you've got a pair, you have a square. So we have a square number, and that's the square number found. So we've got 3 times 3. So 99 square rooted is equal to 3 times 3 times 11. And that means you've got 3 squared times 11. And you can square root the 3 squared. You can't square root the 11. So you square root the 3 squared, you get 3. So once you realise this, you can just see every time you get a pair, you can take that out. And then the other numbers, which are not paired off, you leave inside. So you get 3 root 11. 5 times root 10. Now that's the same as the square root of 5 times 10, which is equal to 5 times 5 times 10. And then we got this pairs thing going on again. We just take that 5 out. Sorry, that's not a 10 there. Oh, that should be a 2. 5 times 2 is 10, not 5 times 10. So 5 times 2, 5 times 5 times 2 is the same as 5 times 10. So we have a 2 here, 5 root 2. Right, next one. Have a go at this. Right, here we go. 125 times 15. Rather than multiplying these out, let's look at the numbers that go into them. So 125 is the same as 5 times 5 times 5, and 15 is the same as 3 times 5. Put those all together, and we get 5 times 5 times 5 times 5 times 3. And you can see you've got one pair of 5s, so that's one 5 that's going to come out. And you've got another pair of 5s, so there's another 5 that will come out. So we're going to take out a 5 times a 5, and that will leave us just the 3. So the pair of 5s, when you square root it, it just gives you 5. When you square root these two, you just get 5. So we get 25 out here, and we get a root 3 in there. This one, well, we've already got 6 times 4 outside, so 6 times 4 can go outside. And then we've got 15 times 3, which is the same as 3 times 5 times 3. And we can see we have another pair, which when square rooted gives you one number that will come out. So we get 6 times 4 times 3 coming out the brackets. So 4 times 3 is 12, times 6 gives us 72, root 5. Okay, we're going to look at some fractional square roots now. Okay, so we're going to start off by expanding these, well, not the fractional ones. We're going to start off with expanding these brackets. Just check you can expand your brackets. Hopefully you'll remember a thing called FOIL. If not, introduce you to. Okay, that will help you multiply out the brackets if you do it properly. So 30 seconds to have a go at the first one. So FOIL stands for first, outer, inner, last. So we times what we've got here. We've got 1 plus root 11 times 1 plus root 11. So we times the first two things together, we get 1 times the outer two things. 1 times root 11 is root 11. Times the inner two things, 1 times root 11 is root 11. Times the last two things, we get 11. So 11 plus 1 is 12. And we've got two lots of root 11. So we write 2 times root 11 here. Let's give you 30 seconds to have a go at the next one. Right, so do the same thing. Let's write out our first, outer, inner, last things. So first, outer, inner, last. First two things times together, 8 times 5 is 40. Outer two things is 8 root 5. Inner two things is 5 root 5. 5 times root 5. And last two things, root 5 times root 5 is just 5. So we have 40 plus 5 is 5. We're going to get 8 lots of root 5 plus 5 lots of root 5 will give us 13 lots of root 5. Okay, we're going to try and turn these into fractions where the denominator is rationalized. That means no square roots in the bottom. See if you can think how to do that. You 30 seconds to think about that too. Right, so the way to do it is you times, in these ones, you times by whatever's on the bottom. So 1 over square root of 7 times top and bottom by the square root of 7. You do not change it because you're effectively timesing by 1. So 1 times the square root of 7 is the square root of 7. Square root of 7 times the square root of 7 is 7. So our answer is square root of 7 over 7. You can see the denominator no longer has a square root in it. So have a go at the next one. Okay, so do the same thing again. What we're going to do is we're going to do 21 over the square root of 6 times top and bottom by the square root of 6. We get on the top 21 root 6. On the bottom, square root of 6 times square root of 6 is 6. Now we want to do it in the lowest terms. So 21 can cancel down with 6. 3 goes in 6 2 times. 3 into 21 goes 7. So our answer is 7 square root of 6 over 2. Right, now we're going to put all that together and try some trickier questions. Zoom into this so you can see it a bit more. Zoom out even. Right, there we go. Have a go at this without a calculator. See if you can do this without a calculator. I'm going to give you, I think, 60 seconds to have let's get started from Okay, so how to do this one without a calculator. Just scroll down. We've got the square root of 11.8. So we know that's going to be bigger than 3 because 3 squared is 9, and we know it's less than 4 because 4 squared is 16. You know that 1.18 is 1.18. That's quite straightforward. And we know that 1.18 squared is going to be bigger than 1.18. You shouldn't be able to work out 8 elevenths because that's 1 and 3 eighths. Sorry, not 8 elevenths, 11 eighths. Well, that's 1 and 3 eighths. And 1 and 3 eighths is a halfway between a quarter and a half. And most people know a quarter is 0.25 and a half is 0.5. So halfway between that would be half of what? 0.25, which is 1.25. So that gives you 0.375. So we got 1.375. Now 1.18, we can't roughly do this because 1.2 squared, if you think about it, it's the same as 12 squared divided by 100, so that's 1.44. And 1.1 squared is 1.21, which means this number comes in between that. So we're going to have to work this out. If you haven't got a calculator, I'm going to show you an easy way to multiply this out. If you write 118 and 118 in a square grid like this, and draw diagonal lines across here, then in each square times the things together. So 8 times 1 is 8. Put a 0 there and an 8 there. 10's units. 8 times 1 is also 8. 8 times 8 is 64. 8 times 1 is 8. 1 times 1 is 1. 1. 1 1. 1 times 1 is 1. And 8 times 8. Then we just add up the diagonals. So that's 4. 8 and 6, 14, 22. So you've got 2 there, and we've got to carry 2 across to this one here. So we've got 2 plus 8 is 10, 11, 19. 1 over to this one. Add up this diagonal. 1, 1, and the extra 1 is 3. Only 1, 1 there. So 118 times 118 is 13924. Now what we do is we count up the decimals. So we've got 1, 2, 3, 4 the decimals. So 1, 2, 3, 4. The decimal goes here. And we can see it's bigger than this number. So the biggest number is the square root of 11.8. The next biggest number is 1.18 squared. The next biggest number is 11 eighths. And the last 8. Obviously easy if you've got a calculator, but if you're doing a non-calculator paper, not so easy. So give you 2 minutes to have a go at this one because this one's a bit trickier. Let's see how you get on with it. Okay, so right, how do we do this one? And there's a little trick to this one. We're going to do a times 10 to the 5. Let's just do this bit first. Plus 2a times 10 to the 4. And the trick is to make the powers, the 10 to the 4s, the same. This is 10 to the 5. So if we do take out, that's the same as a times 10 times 10 to the 4. Plus 2a times 10 to the 4. And then we can see that that's just 10a times 10 to the 4 plus 2a times 10 to the 4. And then we can take out a common factor of 10 to the 4. So you take out a common factor of 10 to the 4, you get 10 to the 4 times 10a plus 2a, which is 12a. And that's going to equal 9600000. Yep, that's 9,600,000. So we can cancel out the 10 to the 4, which is the same as 10,000 times 12a. So cancel out the noughts next to it so we can see it more easily. One nought there, one nought there, a nought there, a nought there, a nought there. Oops, missed one out. There. So we get 12a equals 960. Okay, and we know that 12 times 8 is 96. So a will equal 80. Okay, in this one. And then we can check in the next one and we'll see that it gives us exactly the same answer. So we're going to rewrite the first bit here. A times 10 to the 5 is 10a times 10 to the 4 minus a times 10 to the 4. And that gives us 10a minus a is 9a times 10 to the 4. Okay, and that is equal to 72 5 noughts. And then what you can see is 10 to the 4, you get 9a, cancel out the 1, 2, 3, 4 noughts is 720. And you can also see that a will equal 80 here. Not sure why they need both the equations. There you go. A equals 80 for both. Right, just to finish off, one last one. Try and work out the lowest common multiple divided by the highest common factor of this. 2 minutes to do that. Okay, so we've got 280 and 60 the product of prime factors. We wanted to find the lowest common multiple, the highest common factor. So let's just write these out. I'm actually going to write them out without the powers. So you've got 2 cubed is 2 times 2 times 2 times 5 times 7. And then we've got 2 times 2 times 3 times 5. So to find the highest common factor, we want to see what goes into both. Well, there's a 2 and a 2 that's common to both, and another 2 and another 2 that's common to both. And there's a 5 and a 5 that's common to both. So that gives us our highest common factor. So our HCF is equal to 2 times 2 is 4 times 5 is 20. Now the lowest common multiple will equal exactly the same as the highest common factor times by the rest. The rest being the 2, the 7, the 3 that we haven't got accounted for. To do 20 times 2 times 3 times 7. So we can therefore realise that the lowest common multiple divided by highest common factor, well, we just cancel those two things out to leave us 237. So I could 2 times 3 times 7. I don't need the bottom because I've cancelled out the 20s already. So I've just got 2 times 21, which is 42. So that's the end of that. If you want to get more practice on this, okay, we go back to the first page. You'll see there's a link on the first page when you download this OneNote, and this link will take you to the page on My Maths where this came from. So if I just show you that. Here we go, we've got My Maths. And you can either log in if you've got a password in your school to log in, or you can just go in and practice these questions. So all in exactly the same format. You can go in, but you see the numbers have been changed for some of them. Okay, so go in and practice this after this video and make sure you understood everything that we went over.